to 50% of your fractures produce 80% of your hydrocarbons.
That lends a lot of credibility. If you come in and can be upfront and honest and say, actually in this application, I think this product over here that I don't represent would be better for you. That all of a sudden now you become a trusted advisor rather than a salesman.
And I often say that we have all the requirements of space, right? Because it has to go underground and send us data from miles and miles away, and it has to work. Like, failure is not an option.
We'll put on, a standard mule shoe. Ours is slightly different just for that, but it's, everybody's got one.
The top drive and the drawworks really don't care whether the electrons coming at it are from a joystick or a PLC.
The panel, what you see here on the left, which is now controlled by one of my students, is showing you actually the control of our brakes.
As of now, geothermal is a pretty small market.
If you have tortuosity, the casing will be up against the side on part of the well. There won't be any cement there. The cement will have crescent around it.
So managed pressure drilling, it's been defined as a process to precisely control the pressure profile in the wellbore.
The key is being transparent with our clients in this case. So tell them what happened. If we had a failure, tell them exactly what happened. Whether it's our fault, whether it's whatever the issue was, we need to be transparent.
I think it's very important for everyone in the industry to know what's out there and kind of what's happening downhole as well.
I've probably worked on over 40 different performance limiters in my career. If I miss any of those and the computer is raising weight on bit and I miss any of those, I have a train wreck. The computer's going in the ocean.
Here's your new colors, here's your new thing. We won't do that at all.
Here's the tattoo you need to get.
Yeah, here's the tattoo. Sorry about the last one. We used to fake that all the time.
Hey everybody, and welcome to the Vidor Locksmith Show, where we are unlocking the secrets to success in the oil and gas energy and industry. Sorry, man, I can't even get through the beginning without messing up. Industry, one interview at a time. I am your host, David Gibson. I am super excited to be here with you guys again. This, getting the show kicked off again and getting into, I guess we could say, season 3 or season 2.2 or wherever we're at. Absolutely enjoying this. This is such a great day. We're going to have an absolutely amazing episode with you guys today. I don't know if the comments thing is working or not, because we've only got 2 comments that have come in so far, and one of them's from me. Kind of odd. Anyways, we've got Victor Campos, who is watching today. So Victor, thanks for tuning in. We appreciate it. Oh, we do have a LinkedIn user tuning in from England. All right. I wonder if the notification went out. That's odd. Looks like everything's now we're starting to get some of the stuff coming in. So Ricardo's always watching the show. I do appreciate it. Let me know where you're watching from, and let me know. I've got a random question for today. What was the first rig you ever worked on? Tell us that in the comments today. I want to see where you guys have. What was the first one you guys ever stepped foot on? We've got JP Warren, who is in here today. Hello from Fredericksburg, sitting on the porch. I have to say this. JP is absolutely hustling. He's got a podcast called Around the Rotary. If you guys haven't seen it, go check into it. Go give it a listen. Absolutely amazing. This guy just started a handful of months ago and has probably already put out more episodes than I have, and I've been doing this for a year and a half. So good on to JP and being able to do the hustle and getting the word and the message and being able to bring all of the humans that are in our industry, amazing people, and being able to let them tell their stories. So JP, thanks for tuning in, man. I really do appreciate it. We've got India tuning in, Dallas, Texas. Hey, that's where I'm from. Scott, thanks for being here. Elena from Argentina. This is a international show, by the way, you guys. Randall Thomas. Oh, he was on first rig STAFLOW in West Africa. What a place. My first rig was on Barrow Island in Western Australia. Barrow Island is a Class A nature reserve. This is one of those places that the island broke off from the mainland of Australia, and Australia is already, all on its own. So it's got, koalas and kangaroos and stuff. So this little island broke off from that. So there's even more rare species and stuff that are on that island, and I got the opportunity to go out there. It's absolutely amazing. One of those things where like even Australians, if they wanted to go there, they couldn't. And I got the opportunity to be able, that was my very first job. So absolutely enjoyed it. So, hey guys, so here's the question. Where are you watching from, and what was the first rig you were ever on? So tell us that in the comments today. Philip Hurry, first in was E&I We Talk in Malaysia. All right. We got the guys from Algeria watching. Algeria always bringing in a huge audience for us. So we appreciate that. Zach Gray from Fort Worth, my hometown. Neighbors Rig and Bass Strait in Australia. Bass Strait was my second rig. My first offshore rig was in the Bass Strait. So that's cool. So we got Robert watching from Scotland. Thank you guys so much for being here and watching and tuning in. I mean, trying to keep everything organized as we go through this. So don't really have much news for this week. Other than the fact that we've had a lot going on in the industry. So I can't really think of anything specific. So anyways, what we'll do is we'll get to it. Today, we've got an amazing conversation about drilling automation and all the drilling mechanics that are drilling robotics that are going on at surface that help us to be able to drill faster. So we've got two amazing guests, Fred Florence and David Reid, and I will bring these guests on right after our quick little commercial break. And I should say, this is the news for this week. Sorry, I'm just now getting my brain wrapped around what's going on. We just had the season finale of season 1 for How It's Done. If your company is interested in being on the How It's Done series, please reach out to me and let me know. If you have a company in mind or something that you would like to see in that series, let me know. And from what I have heard, I've had some people give me some feedback that there are very large operators who are watching these videos and being able to get information about the companies that they potentially use and procure services or products from based off of the videos that we're putting out. And they are requesting that we make even more of these so that they can see even further into some of the industry. So this is legitimately from, I would say, within the top 5 operators in the world who are saying that they are watching these videos. So it is worth it. If you guys want to be a part of it, please reach out to me, let me know, and we'll get you guys on there. So season 2, we are starting the filming probably within the next week or two. We're going to get everything filmed, put together, and then we'll start releasing the season as soon as we get everything done and taken care of. So here is the quick intro for the How It's Done, and then after that, we'll have our guests on. All right, everybody. Now, hey, do me a real quick favor. Tag your friend in the comments so we can get more people watching the show, because this is awesome information. Like, share, subscribe, do all of those things. But more importantly, just share what we're doing with your friends. So without further ado, we have the amazing Fred Florence. Fred, thank you for being here on the show today, sir. I believe you're on mute, but that's all right. We just heard you say thank you. I think that's what you said.
Thank you for the invitation.
No worries. And then also the notorious David Reid. David, thank you for being here, sir.
Thank you. Glad to be here.
And I should probably take this portion of it off so that we can actually see you guys there. So, Fred, David, you guys are going to have a conversation about drilling automation. Give us a little intro to what you guys really want to be able to talk about today.
David?
All right, I'll start. Well, for me, it's the journey we've been on for everyone to understand the struggles we've had getting here, and having Fred and I together. It's we've joined in a lot of that stuff together, so I think it'll be fun to kind of walk through.
Yeah, for me, I got involved in drilling rigs and then controls for drilling rigs. And when I started seeing some of the controls, I said, oh, wait, we can tie the surface and downhole together and do things we couldn't do before. And now it's starting to happen, so it's kind of exciting.
Well, thank you, guys. All right, Fred, if you've got the screen share, if you'll do that one, then I'll be able to go ahead and get that brought up. While we're waiting on that, let's go through and see some of these here. So we've got Dane Greaser saying, good morning. Great to see our industry making a positive and slow turn in the right direction. Yes, definitely. And actually, Dane made a post today. They are actually hiring. They're looking for somebody. So go check that out. If you're not connected with Dane, go and look him up, or at least look for the thing there. We've got Bale saying Casey Dutag Rig T-75 for the first one he was out on. We've got a LinkedIn user. Don't know who this is, but they said Santa Fe Britannia jackup in the southern North Sea.
That's good.
I'm guessing you guys are familiar with that rig.
Yeah, Deutag too. Yeah.
Abbas is saying Iraq EDC ROM 4 Rig 25.
Yeah.
Let's see if we got anybody else that said here. Noble Linda Bolser 2005 for Donald. Yeah. So some fun offshore rigs. All right, let's get back to, we've got the stuff pulled up here. One more. Adriatic 11, 1992.
That's funny.
All right, so add to stream. There we go. So Fred, take it away, sir.
So I wanted to try to pull up a video here, and it's probably 70, maybe the mid 70s. And I just wondered if you get a chance to look at it, do you see anything unsafe? And I wanted to give you guys a few minutes to send some comments back to David and say, what in this video do you see that might be unsafe?
What a classic floor you got there, Fred. That's interesting. This is a series. This slide deck is a series we've used to teach for a long time. I think we always start with this video.
I've always started with it, and the most common answer I get is, "What's unsafe?" They say everything.
Yeah.
And
well, if you, I mean, I think when we started, it was common to see a chain thrown, but I think nowadays it's really rare.
Very
people actually will catch that and see it and understand it. Even the way everyone worked together back in those days. I mean, it was a well-oiled machine, but it had a lot of risk in it.
Yeah. I have a friend that lost half of 2 fingers, and he walked into a British pub and he would say, "I'll have 2 pints and 2 halves, please."
It was sad, but it was true.
But it really wasn't.
It was normal. It was normal. Everyone had fingers missing, and it just wasn't okay.
So anyway, we'll move on a little bit. I want to show a screen that's probably from the same time, and then about 20-25 years later, the difference is that the video is in color instead of black and white, but the rig looks pretty much the same. And then this is one from about 5 years ago, and there's a little bit of electronics on the rig floor and some safety mats, but other than that, it's still the same picture.
You know what struck me the most, Fred, was in that environment, the machines were available. The technology was starting to be available. It wasn't adopted widely in all these applications.
Right. Well, you see the red chain tongs in the foreground here, and then up to the top in the left, you see a pipe spinner. So instead of a spinning chain, we've got a pipe spinner. And what a lot of people don't realize is how many fingers got crushed by pipe spinners as well. So it took a while for us to kind of get where we were going. And so just wanted to talk about that a little bit. And then because of spinning chains and tongs, David and his team started building iron roughnecks.
Well, it wasn't me in 1975, but it was around the same time, interestingly, because George Boyjeff inside of Varco was one of their new engineers, and he immediately started moving to adding the spinners and the torque wrenches. And I think within a year, he had this idea that you can kind of see on the right there, which was an integrated slip, which I think did happen once or twice, but wasn't common on roughnecks. But this idea of a roughneck. But if you think, I mean, gosh, when was it? It was probably late 90s that roughnecks really came in the U.S. We had them, but we just didn't see them. So on land, it wasn't until we made a cheap enough, small enough machine that was simple enough that people could use. But it was amazing to me I think when I got out to Orange and started to realize that the US didn't have a lot of roughnecks, because in the UK you would see them offshore, a lot more common than an offshore rig. And so yeah, we went through those years. So 1975 all the way through was quite a journey from just inception and idea. I think I have a 1975 or 1976 picture of OTC. It's quite amusing, but it has that same machine on it.
Jerry Gill dragged me into the NOV to the Varco booth and showed me Bigfoot is what they called it, right?
That's right. Yeah. In fact, the first one was the first one they painted the name Igor on it, which a lot of these machines got actual names. And I think our competition's first product, they called it an Igor because they assumed that was actually the name of the product. So, but yeah, there was Jerry. Jerry was something. He was a convincer. It's great.
So here's a new view of it.
You go still with the slips, which we have systems to run the slips, but we're still manually running them, and that's the ST80 there. So that really was the turnaround in the machines. I think there's tip points in our industry where products become, more common, and this, I think it was late 90s, just suddenly went wild and became acceptable because we had the right machine. In fact, we developed it with Shane Marchand. He was the young engineer working on the ST80 in Orange. I don't know if you remember, Fred, but our first Spin Torque 80 concept was painted black and had legs on it. Like it ran like a normal roughneck. Do you remember that?
No, I don't remember seeing
had a PLC, and that's when H&P jumped in and said, yeah, but no. We don't need it driving on the floor. We don't need tracks. We need an arm. But Shane took that prototype out in Orange and sat on it until it was right. And if we didn't have H&P's help, I don't think we'd have had the ST80. But they integrated the spinner and the tongs, and that was probably the best thing about it. Was a compact unit. It was a big breakthrough.
So you see in the picture in the middle, the red and the black pieces, you see a power slip and some remote operated elevators.
Yeah.
So all of these pieces had to come together to automate the process.
Yeah.
And they didn't all come at the same time. So it was step one of mechanization, step two, and step three. And then eventually somebody said, how do we start tying these things together? So everything you've seen up to this point has been stuff on the rig floor. But there's a lot of things with pipe handling that occurs that's not on the rig floor.
Yeah. So look at some of these dates, Fred. This is 1949. That's in let's see, Round Top, is it, or Round Rock? It's Round Top.
Believe it or not, that's older than me. I know.
Yeah, well, they have. It's an interesting era because post-war there was all these inventions that happened in our industry. There was some submarine rigs, and on those submarine rigs there were top drives and pipe handling. Funny enough, in the concept.
Wow.
But this was an idea. It really didn't kick in until offshore, and when we started doing drill ships, was when I think the original ones, they'd lay the whole stand. I don't know if you got to see one of those systems, but they were pretty impressive. But also very manual, still manual. But they'd lay the whole stand down on the original small drill ships. And then as they took on that BJ design from 1949, so about the 60s, everything that floated, you'll see they have windows in the derrick and these arms that stick out. And they just had this big steel arm that would be used to rack the pipe. And because of the window and the way it racked, it meant everything that was normal for racking. So taking your heavyweights and sticking them near the front end of the fingerboard to be able to manually get between well center and the fingerboard. They're actually on the back because the racking machine could only work from the back forward because it was actually it was feeding from the back. So it was an interesting machine. But I mean, it was common. If you look at any older rig, you'll see those arms sticking out, 2 or 3 of them. Yeah. And then in the 70s, they kind of designed this monobeam type design, which bridge cranes, we still supply those today. But they brought the whole machine inside, found a way to take the upper end, and actually in the first ones, they all lifted up on the upset. And then it wasn't until about the mid-80s there where you see I think that's a PHM there from Varco. And I think they did the automatic roughneck first, probably the year before 85. But in those days, they actually made the hardware and the software. So there wasn't a computing device. And I think you were probably doing the same in BOPs at the time with Schaefer, I remember, because they had like mil spec. You couldn't buy the components.
Right.
And everyone was having to invent the technology because the computers didn't exist. And so that was the column racker was originally with a roughneck attached, because they basically built this racking machine on top of the roughneck, the PHM. And then the 90s, we had that was kind of a North Sea push in the 90s. There's a star racker there, which was a column racker that didn't drive back and forth, and it racked in a different way. So it was radial in its design. And then 94 was really where Norway helped us out, because we'd been making transfer systems, taking tubulars from the deck up into the floor, but they legislated in 94. So I think Maersk before that and Santa Fe were the only ones who really had tried using some of this handling technology. But it wasn't until it was legislated in Norway that every rig had to say everything under 20 inch, you have to use a mechanized tool to handle it. So that changed our world. That's kind of when I came in. That's when I was running all over Norway measuring for these systems, trying to see if we could get some of that business.
What has the industry settled into? Here's this line of evolution. Kind of where are we now?
That's good. Well, so today I would say on floating rigs, just like the beginning here, on the floating rigs, you see a lot more intensive pipe handling, that everything is handled from riser. I think what was funny in 94 was we weren't handling riser. So you had small tubulars being handled and riser still being manhandled, which was crazy. But today, all of that on floaters, semis, drill ships, you don't see any of those getting built without complete hands-free. But interestingly, jackups, still some manual handling. And they'll probably have a monobeam like that 1975 design, a bridge crane. Sometimes the higher end jackups do have full column rackers, and they do have transfer. So if you take like a Maersk or the large jackups that go into Norway, and they're all fully pipe handling. But there's a lot of them out there still have some manual handling out in the deck and some pipe handling assist. And then when you get to land rigs, the interesting thing is they really went to transfer conveyors basically. So the pipe handling out on the floor is carried over by a machine. Highly automated is still it's still happening, but we had a dream back then that I think original. If you look at the 1960s SBE papers, the whole business case was less people. And then you look at the column rackers where the whole thing is one machine ran by one guy, and the idea was less people. And what really happened was more people with more qualifications were needed, and a lot of frustration on the journey where you weren't delivering what was expected. You were getting safer. Deep water wouldn't have been able to happen, I don't think, when we went into the 10,000 feet range without large machines. But really people have bought into the safety side more now from a mechanical standpoint, and automation. The idea that you push a button and everything works, that's still more rare than you would think with these machines. In fact, I think now we're testing out some industrial robotics, the type of machines that build cars, to do all the work that we didn't consider, because all these machines do the mass heavy lifting, but the small work gets left alone. So there's still a journey ahead of us.
I want to jump in here real quick, guys. We've got a couple of questions that have come in, and let me do this real quick, since that way they can see you guys better. So, whoops. Of course, we get another question right there as soon as I'm about to click on something. So I'm going to ask, what do you think is the main driver was for mechanizing, safety or cost?
That's an ugly question if you want the truth.
Just give us the ugly truth then.
Well, I think originally it was. I mean, you look at the drill ships. Of course, it was safety, right? It was the prime concern, but the justification on cost had to be there, and it really didn't deliver. That was one of the hard things. It was so primarily if you didn't have the cost picture, they would still rather just tell everyone be safe, right? Let's have practices, because it was much cheaper than running a big machine. So it wasn't that there was a lack of safety. It was just that if there's another way to do it, the drilling contractor has this expensive asset, and maybe Fred can answer this better because he was both. He got to be inside our world and drilling contractor. But I think the idea of adding any asset, any cost to your asset or new process is pretty ugly. I don't know what you think, Fred.
I agree with you that the main driver was safety. for sure. And there were a lot of inefficiencies in how we handled the pipe. Part of it was because things broke. And so when they break, the drill crew has to be able to revert to manual. And it took years for the reliability to be acceptable, so that if there's downtime, it's small enough downtime that you could actually turn the drill pipe around and you could have the pin up towards the derrick instead of hanging on the other end of the catwalk. So if it failed, you really couldn't go forward. But it meant that the system was much more efficient and faster.
Yeah, I think every machine we showed so far had the requirement that you could go manual. Right. I don't think until we hit the 10,000 feet deep water boom, it was the first time we started to make systems. In fact, that's when you and I started working together with Noble, if I remember right.
It was.
On the first PRSs. But yeah, that was the first time we did a setback that actually the fingers point in towards well center. That was when things changed.
Well, I worked on the Sedco 472. I had a stint as a young engineer in the field, and I came back to the office, and then I went out on 472. And I thought it was a big boat. I thought it was a pretty good sized drill ship. And when you saw the drill ships that were coming out here 10 years ago, it's 4 times larger. I mean, here's the 472, and these others are twice as long and twice as wide. And one of the problems we had, of course, is you couldn't put that much weight on the deck. So we had drill pipe that wasn't as high as the rig floor. It was down on the main deck. We had casing that was in a casing hold because you couldn't handle it anywhere else. And we had all these really complex systems to try to pull all that together.
That originally, Danny Atkins, I guess, was a Sedco man as well before he was a Noble guy. But he was the first guy to say, he's probably the turning point of parallel racking. We designed it for Maersk in a concept that eventually got kind of leapfrogged over and got built in another era. But we'd put the PRSs at the time with the fingerboards pointing in. But Danny and his EVA program, which was to take really old submersibles and convert them back to or into semi-submersibles, and we had no space. But he wanted all of the setback lowered, just like the rig you're talking about. I think Douglas Carver he mentioned as well that had a similar like lowered setback. Because I know in our days in the late 90s, people thought they were inventing it for the first time, But strangely enough, you go far back enough, there's things we did before, right. And that was one. It was all stability challenges, and those rigs rocked and rolled. Yeah. I mean, the motion on those compared to a large drill ship now, it's not comparable.
Very different.
Yeah. So another question here: what do you anticipate will be the next big technology/automation to be widely adopted in the industry? Thank you for the question, Adam.
Adam, I see. Well, let me back up. I got involved with control systems, integrated controls. So we had a top drive with a programmable, a programmable logic controller, PLC, and then we had pipe wrapper with the same thing. We had all these different pieces, and we started pulling them together and putting the driller in a chair in some kind of integrated fashion. And so that was still mechanization. It was integrated mechanization. And previously Mohammad used the word mechanization. That's right. It was not automation at that point. It was mechanization. So machines are doing the heavy lifting for the people. And then when I was looking at it, I went, we've got this big fancy machine and computers. We need to tie that to what's going on downhole. And to me, the true value proposition for drilling automation is problem avoidance. There's some things that we can do to drill better, faster. We can react to changing formations based on vibrations. We can do lots of different things there. This is now automation. So the machine is running, it senses a change in the rock, and it changes the drilling set points. That's automation. And so there's things along those lines.
I remember actually, I think it was 98. I actually posted this morning that you and Walt Aldred from Schlumberger, you both worked together before, but you came up to me in a drilling conference. And I remember it was it must have been 98 or 97. It was definitely the edge of falling over another boom. and you guys were so excited. I always describe it like you were kids, because you had this aha together. And maybe this was you talking. I don't know what had happened before that, but you're just like, we do the surface equipment, like we control it, and he controls what's downhole. We could connect it. It'd be amazing. You had this like real excitement. I was like, okay, cool. Like,
the actual conversation with Walt was at one of these conferences, and I said, we've got this $1 million machine that just controls the drill pipe. And he said, well, we've got a laptop, and we give it to a guy, and he goes to the rig, and it comes up with all these recommendations to the driller to say, if you do this, it'll drill faster. And at 3 o'clock in the morning, things break. And they all go up to the rig floor to find out what happened. And they say to the driller, what happened? These are Walt's words, not mine. And he says, what are these words? And that's something I should have turned off earlier. Anyway. It's okay.
No worries. We're only live.
Okay. Anyway, so Walt, they go up to the floor and they say, what happened? And he said, well, I was drilling along and I thought I could go faster, so I did. And he said, what happened? He said, nothing. So what'd you do next? He said, I went faster again. So he got to a limit, and the limit had some kind of safety factor in it. And eventually he went too fast and things broke.
Yeah.
And so I said, well, if we can take our fancy machine and your algorithm, we can really change the way people drill and make it safer. And that's when we came dancing into the show. And
you were so excited. But what happened, if you think it through, I mean, all of that, we're now, that dream, now that's becoming, I wouldn't say even normal yet, but it's spreading fast. This connectivity, running the machines by what's happening downhole, and creating windows and envelopes. And we've talked about it when we started the DSATs group. That was kind of, that all births out of that conversation with you and Walt. And then I think I was with Walt in Brazil and John Thorogood, and we got in this conversation in a forum environment for SPE where, what's possible, and everyone was projecting possibilities. And I think between all of us, we're like, we could do this now. And in fact, you and Walt did it. You want to tell that story?
Yeah, we did remote drilling. So at the time, Schlumberger had a test rig in the central part of Texas, and no one was supposed to know it even existed. So I couldn't even tell anybody where I was going when I left the office. It was that secret.
You were in Austin at that time, right?
Huh?
You were in Austin already by that time.
Yep. But anyway, they set up a remote operating center in their facility in Cambridge, England, and the rig was in Cameron, Texas, and we actually drilled a transatlantic well. So we had a smaller control system, a little small controller that we were working on at the time, and we had that hooked up for remote activity, and so it worked extremely well. The fun part was GoPro didn't exist at that time, and one of the Schlumberger engineers, Rustin, if you're on the line, had his hard hat on, and he had a big camera duct taped to the top of his hard hat, and he was running around the rig floor filming all of this stuff.
Always ready.
Pretty much, you got it. And so we made do with what we had.
But I think that, because that led to Walt and I talking with a large group on this future casting environment of a forum, and everyone was saying this, it could be possible. And Walt's like, we have done it. We've done this already. Let's get on with it. Yeah. And we really came to this understanding. It's not technology anymore. Now it's culture. Yes. Now it's just our resistance to change that is our barrier. And that led to DSATs fundamentally.
Well, let's tell them what DSATs is. Drilling System Automation Technical Section. So Society of Petroleum Engineers, SPE, has different technical sections.
Yeah,
and this one particular technical section is called Drilling Systems Automation. And its goal was to tie the surface and the downhole together in an automated fashion. And their main task was to find ways to deploy this. How do you show people it can be done? How do you hear the arguments about why not? How do you redesign things to deal with the problems? And how do you start moving forward? And so it's been a very active group. And recently we're getting involved more and more in interoperability, so that there is a particular control system and there's downhole tools that have to interface with it. There are third-party companies that come out. There are people now writing apps to actually run on those programs. And all of that has to be done in some kind of common communications protocol and common language. And that's quite the challenge. We've been dealing with this for 10 years, and now we're making progress on it.
There's a new thing we're doing. So there's maybe, I don't know, 3 groups trying to wrangle this idea of everyone get on the same language. In fact, you did one early in DSATs where we tried to just prove OPC-UA, which is I don't even know what it stands for, and I can say it, but you guys were using that as I think we did a test case just to say, look, everyone can communicate together. But I think most recently we've been learning about translation. Like you actually don't need, in the modern world, everything to be in the exact same language. You just need good translators, which is a whole, that's right on the edge of new for us. But I know it's not for other industries, but we're kind of catching up and gaining speed, because that becomes a blocker to being able to collaborate, which is critical for these systems.
Well, one of the advantages of OPC, it's an open process control. That's not what it stands for, but that's the easiest way to understand it. It's OLE for process control, and that's too long a story. Yeah. But one of the advantages is the 2 machines can shake hands and talk to each other and say, what can you do? What can you give me? And so what we're working on right now is the semantics, so that we can program this so that when the 2 machines shake hands, you say, okay, I have a device out here, and it's a sensor, and it's located in this position. It was calibrated at this time. It has this reliability, this accuracy. It has all these different elements that go with it. And then they're going to take that sensor and maybe it's a pressure transducer. And from that pressure transducer, we're going to infer a specific parameter of drilling. And all of that can be done in a semantic manner. And so instead of having to change the tag list every time you go from every time you add anything to a rig, you don't have to start over again. All this stuff will be very simple. And when a third-party company that's doing managed pressure drilling, for example, wants to plug into the rig, it can be this company or their competitor or their competitor, and they'll all be able to interface using the same kind of technology.
Yeah, it's quite a challenge ahead of us, but I think the definitely the next phase is this communication, but learning how to make systems work together. I think the more we solve those problems, the faster this goes. You jumped into apps without, us even kind of walking people through what happened, because this ability for platforms to be able to talk to each other and to have other people's software on top. Historically, we would never go there. If you go to the beginning of the DSATs group, I don't think anybody was thinking, we'll all collaborate. We just thought first one to get there wins. Right. And everyone was going as fast as they could to develop their technology. And we've really had to learn how to have systems and platforms that allow each other, as well as, we previously blocked out small companies, and that's changed since then. The large companies would be controlling so much, and now creating platforms that startups can get on. And I think one of that theme or that thought as it evolved probably drew you into some of the work you did or are still doing with Drillbotics. I think that's an interesting approach that we've taken.
Well, backing up a little bit, I was working for Bob Bloom at one time, and that was at Barco. Before NOV, and Pete Miller was the CEO, and Bob said, let's go talk to Pete about automation. And I held up my phone and I said to Mr. Miller, we make the iPhone and we get 1 million free programmers. Yeah. That was my vision of drilling automation.
Yeah.
And so one of the things you mentioned, Drillbotics, we were trying to find a way to engage with the student and the academic community within DSATs. And I was at a forum in Paris actually, and I was talking with Gerhard Tannhauser from Austria, and he built a little mini rig that he had in his university class and laboratory, and they drilled rock and made measurements, and he taught his students about drilling and about drill string dynamics and a number of things. And those students have produced some fantastic papers as a result of their work. They're really worth reading. And then I said, well, everybody likes a contest. Let's have a competition. So we decided to have a student competition to build a mini rig, to design and build a mini rig and drill a rock sample. And that was the name of it. It was the DSET student competition. And John McPherson said, Fred, that ain't gonna work. Go find a name. And so I went out and started Googling everything I could think of. And I hit on something called Drillbotics, and it wasn't taken. So the next day I went in the office and I said, what does Drillbotics mean? And everybody said, I don't know. And I said, well, what do you think it means? Drilling with a robot. I said, got it. And I secured the name and got a trademark on it, and we're off and running. This is our 7th year for this to happen. We've had 64 teams over those 7 years. We've had just under 300 students, and I think we're in about 15 different countries.
Yeah.
And, last week we had somebody register from Kazakhstan, so we're spreading out even further. But the fun part is the students from A&M used mechanical specific energy. They measured the response of the system, and so they were able to tell if their bit was going from a soft formation to hard or hard to soft, and they could determine that from the vibrations that they were measuring, and they could change the drilling parameters on the fly, and they've applied for a patent for that.
Right.
Wow.
And so this is not a science project. This is a research project, and they're doing some amazing work.
What it really did was it gave us the ability to have students start their transition and actually impact the industry from being in the student body, which is a dynamic we weren't quite ready for, but in truth, their ability to collaborate because they're not in companies has been really powerful for progressing the science, right?
Well, I'm an old guy, so I call them kids. They're not kids. They're all in their 20s and some in their upper 20s, and some are maybe even older. But every time somebody in the industry tells me that we can't do something, I say, fine, we're going to give it to the kids, and then they'll show you how easy it is.
Yeah.
And they do that.
Yeah.
And so what started as a brainwashing experiment to get students that could become drilling engineers that weren't afraid of automation became a research project, and now it's actually spurring development in the industry. They're amazing people. These young women and men are just doing fantastic stuff.
I didn't see you there, David. Are we on your show still?
I'm enjoying the conversation. It's like we're all sitting around at dinner and there's 100 people watching us, or 100 people watching you guys talk, and I just happen to be sitting at the same table. So Fred, I should ask you if you want to go back to your PowerPoint presentation at all, or do you guys want to try to fire off at some of the questions that have come up?
Just keep talking.
All right, so I have to bring up Adam's question again because you guys completely pulled a political debate answer here and didn't actually answer the question.
We did. It was just hidden in there. You have to pay attention.
So
I did, Adam. I think it's going to be more applications from other people that are minimizing the failures and mistakes that cost us tons of money. So if you miss a kick and it gets too big, if you get stuck, if you're packing off and you don't know it, if you're damaging a motor, right now there's some really experienced people that have left the industry, and there's some inexperienced people that don't understand what's happening now. And so if a driller doesn't know that he's got a mud motor that's sticking and getting ready to chunk, and pieces of rubber are going to come spitting out of it, he's going to damage this, and it's going to mean a trip to be able to continue drilling. And so it's all these things that you can tap the person on the shoulder and you can say, double check this and make sure. And eventually that it may be fully automated, but right now it's using the data in the machines to optimize what you can and tap them on the shoulder for the other things.
Well, this leads me into the next question. It's a great question as well. And it's, guys, if y'all can, try to keep the question short because then it's almost covering up all of Fred down here.
That's right. That's better.
Well, here, I'll move there. It'll cover me then. The balance between automation and mechanization, do we think from a hardware perspective, much more change is going to be needed, or is it primarily software that will continue to be tweaked?
The hardware is there, right? The devices that we need that fit the environment that we're in, we can get most of those for the surface equipment. We need some hardware for downhole that can handle the high vibrations, the higher temperatures as we go deeper and deeper, particularly like offshore Gulf of Mexico. But there, because of the temperature constraints and the spatial constraints within a downhole tool, that's where the work's going to be, and that's going to be on the chip level. But from PLCs, there's many different competitors that offer the same product for PLCs, and I don't think there's a whole lot to be done to worry about on the surface hardware, other than integration, and that's what you've been working on, David.
Yeah, no, I think that's right. There is some from the robotics world that we will need, because I think if you look at where we are, similar to where Fred and Walt were, the thing that comes after is, why do we have to have people on a drilling rig floor? I think that's coming. It's not. There are prototypes out there. There are people doing that, but removal of the cabin, potentially. There's a lot of tasks that have not been mechanized because we went for what we could justify financially, which was the big heavy stuff, to be to still allow us to do smaller tasks. But in time here, I think there's still some more there. I think that will come along. But Fred's right. There is tons, and it's a nice low barrier to entry to get into the software side, and we've actually opened it up enough now that I think we're 140 Nova systems, which is you can get a software development kit and drive the rig, so you have the ability to interface with it, and others have systems like that too. We're not alone in that space, and so that says there's a lot of opportunity for people to come in and offer packages of software and start doing that. So I think there's tons more, and then the language and integration of systems, that's all ahead of us yet.
I don't want to leave, before you go to the next question, I don't want to leave the impression that there won't be changes to the hardware, right? There will be improvements to the robots. There will be additional movements that will be enabled through some of these things for the smaller pieces and for making better use of the space on the rig. So there will be hardware changes, but these are not barriers. These are just improvements.
Yeah.
So a question from Barry: does the U.S. have to wait for government mandates like Norway to make the proper leaps in hands-free automation and mechanization?
Well, we went there without mandates. We went there on mechanization with Roughnecks. That just was a right thing to do. So safety culture drives and drove the design. I believe it's a performance thing. If we didn't have the Norwegians driving, the MPD at the time driving, Norwegian Petroleum Directorate, if they weren't driving the awareness that machines are a right answer, the businesses at the time were like, they were slightly slower, so I don't know, it's a good idea. But we're seeing now machines that are competitive and able to do consistent work. And that was actually a DSAT's learning and early brainstorming is what is the product that people need. And actually consistency is a big deliverer of cash. And we learned that from our manufacturing world too, that you can get the supply chain to line up. There's a lot of savings in just getting the machines in place. And so I think business will drive. I don't think it's required that the government jumps in, but it certainly helped in the Norwegian case.
I have to tell you guys, we have a lot of questions coming in. But first, we have to give a little shout out to Shane saying, the beards are in the house. David Gibson, keep doing what you're doing. Another great show. So yes, You have to have a beard to be on today's show.
It's required.
Sorry, Mr. Gibson, but it has to be gray for you to be on this side of the screen.
If you look really close, there's some down in there. My daughter pointed them out to me this week. She's like, "Why is your hair a different color?" So, yes,
wisdom.
Yes, or lack of wisdom, I would say, in my part. All right, so the next one from Donald: continuous stripping is in use on at least one rig, or at least has the capability. Do you think this will become the norm for new builds, and can it be retrofitted to older generation? Which actually, I would say there's a question within a question here. Are there going to be any new builds?
Yes.
Eventually, there's a lot of scrapping going to go on, but eventually it'll be a while. I think we've gone through the overeating thing we did in the 80s, and so on US land we saw nothing for years because they were cannibalizing forever. I think we did a bit of that, and we kind of knew it in the middle. We could feel as Brazil started saying, "I want all these rigs," and then suddenly China started to match with, "I'm going to build a ton of rigs." It just created a lot in the industry beyond our need. Someday we will. I think retrofitting is a good idea. We saw it before when we were doing all this early pipe handling work. There was no real new builds. There was maybe 1 or 2 a year, but we were still innovating. I think the downturn is the innovation time.
Yeah.
If you can stay alive, but because you've got to do something of value, and it's a good innovation. You know, it's not just because when you hit the upturn, no one cares. It's like go fast once you hit the upturn. So, yeah, go on, Fred.
I want to address something about continuous tripping, and I also want to back up to the previous question and merge the two together. I used to work at Sedco, and I worked for a guy named Dillard Hammond, who was vice president of technology. And Dillard was a great teacher, and I got to know him after later I was working for Varco. And every year at the OTC, I'd see him at the booth, and he'd say, "How many of these you have running yet?" And I'd say 2, 3, 5. And basically, it's this meter, and once it gets to a certain point, he's ready to buy one. But he's not going to be the first guy out there to buy one.
Right.
He was not an early adopter. And that's where I kind of came up. I don't know if I came up with this or I heard somebody else, probably somebody else, said, in our industry, there's a mad rush to be second.
Yeah.
Nobody wants to be first. So here we are with at least one rig that's doing continuous tripping. And so they're going to have to prove that and prove it on some kind of scale before you see wide acceptance. So to make that become the norm, you're going to have to show people that it really works.
And we saw it. This was, if I remember, when you worked for Bob Bloom, and he was kind of resistant to automation at the time. He'd say, "Why are you even having these conversations?" Because we did it in the 70s with the NADM rig, which was the national, I can't remember, automatic drilling machine or something. But they'd built a rig and tried to make it work. Nobody would buy it. It was too expensive. The 80s, we had the Thermi project. Everything was automated. Mud was automated. It was all great, but it was kind of a concept rig. Then you go into the 90s, and we're still trying to build them, but we're not automating like people expected. And then finally, you start to hit a new build cycle, and we've done enough to say this is okay. This stuff is stable enough. We can build rigs this way, and we did. And I think that's the hard part. Is it's a value case of coming through the pains of an R&D project, proving out technology. I mean, and look at wired pipe. I mean, my goodness, we're a couple decades in now, and it's starting to turn up. You know, where it's finally got the cost where you need it to be, got the system reliable enough, and that's always all these machines we've lived through had that same story of cost and reliability and value. And so the question is, how much time do you save? I've watched people do automation projects, spend years, spend millions to save 10 minutes, and you're like, yeah, there was a better way than that. And so there's other things that happened with just efficiency and shale. There's other efficiencies. So I think I think all of us who brainstorm have drawn a continuous tripping system forever, continuous drilling, because it makes sense, you know, to do it. But there's a lot of machinery around it. We had a rig. It was a concept rig called the spread rig, and it looked like the best idea ever. But it would have gone through shales faster. But the price of 2 rigs and the speed wells work started to be drilled. It was irrelevant very fast. So to spend some extra on something that could be faster and better didn't matter because the economics weren't on our side. And I think that's where the continuous tripping system is. There's a lot of cost going into it. It's not near its tip point. And so it's still an interesting project for the early adopters. And it'll come. I think in time we'll work that out. You could say coiled tubing was that dream as well, you know.
Right.
It was a similar idea.
To go back, I have not seen the latest developments of the continuous tripping machine, but some of the earlier machines, I met with people and talked with them about some well control issues that they couldn't deal with their current design. And I think they've gone back and made some of those changes.
They have, yeah. They're looking at it's almost like a CCS of the connection that they're looking at now.
Right. And to pick up what you said about the spread rigs, I shamelessly stole the ideas from you and Frank when I started working on the root rig.
I remember.
And so I think what's going to happen with these types of technologies, like continuous drilling, is everybody from different parts of the industry is going to take a little from column A and a little from column B, and they'll make some major changes over time.
We actually built a jackup that the floor is moving for continuous tripping. So you would have enjoyed seeing it, Fred.
We made a drill ship with a gimbaled rig floor.
Remember that? Wild.
Wow.
It was in 28,000 feet of water, sucking up manganese nodules off the Pacific seabed.
Which is the new trend, Fred, by the way.
The dynamic stresses in the pipe would have been so bad that we had to just eliminate the dynamics. It's crazy. We're in a crazy business.
Yeah.
Next question, because we've only gotten through like 4 of them.
Okay, sorry. Keep firing them.
The drilling industry is going through one of the most significant downturns they've seen. A huge technology breakthrough come out of every downturn. What is what is going to be the main difference between 2019, 2020 technology and 2022 and beyond? I'll add that to it. All right, you guys are just going to laugh on to the next one.
No. I mean, I think there's some great. I mean, what's happening in the data sphere? I think what you're going to see different. This connectivity of systems, and I'm not even now talking between drilling equipment and the well, but when you start to connect to the geology, because we spent plenty of years projecting where we thought it goes, you know, and so we're just getting much closer now with the ability to handle masses of data and have computing systems that can handle it. You start to look at drilling much better wells with better data and live changing models, you know, as well as projecting models. So I think there's a ton out there. I don't think we're going to see that in 22. I think that's where we're going. But in 22, you're going to start seeing much more connected systems. There'll probably be new machine design here and there, but I think that the data revolution and what it will do to our ability to efficiently produce better and get more oil out of the ground is coming our way pretty soon. What do you think, Fred?
I saw Philippe Herb on one of the earlier chats, and he's doing a lot of work with artificial intelligence that's starting to make a big difference. Daryl Fett with Total is leading a group within the industry that involves SPE DSATs. It involves the International Association of Drilling Contractors, IADC. It involves 3 different technical sections within the SPE, and this program, and I can't remember what it stands for, OSDU. And what we're looking at is what do we need to do with the data throughout the life of the well?
Right.
So you have the G&G people doing their work up front, and they create a place and say, here's where we want to drill the well. We go and we drill the well, then we need to complete it, then we need to produce it, then we need to abandon it. And so we go through all that life cycle of the well, and at every point, we have completely different data systems. And so the things that we're working on today is to make that data accessible. Most people who want to study that data today spend more time looking for the data than they do in their analysis. So if we can make that data quickly available to people, that's a help. The second thing is garbage in, garbage out. If you have this data that has a lot of holes in it and it has a lot of errors in it, then what Philippe is working on with artificial intelligence is handcuffed. So if we can define data quality and sensor data and sensor quality, and not just sensors, it's also the morning report and other reports that are out there, purely contextual data that you still have to be able to make sense of the drilling data. And that's where all these different groups are headed, is that once this happens, the overall well cost goes down. And whether you work for a service company or an equipment manufacturer, we all get our funding from an oil company. And the number of rigs that are running is based on how much money they've got. So if we can find ways to lower their cost and get them more value, it'll all trickle back towards us. And so we have to be doing these things in this downturn. And what I think will come out of it will be a much greater understanding of how we really should be drilling these wells.
Yeah, it's good.
Well, speaking of data, and OSDU stands for Open Subsurface Data Universe.
There you go.
I didn't remember it. I've heard it a dozen times as well. But.
First time I heard it was on a live chat show, and they're like, "So what do you think about the OSD?" I'm like, "So blah, 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 I don't even know what you're saying." So the person asking said, "Me neither." So we moved on. Like, okay.
Great questions to ask on a live show. What are the most useful downhole data streams to have, or what are you not getting you would like to have?
Gosh.
Well,
James, thanks for the question. Obviously, you stumped them both.
It's an excellent question. And, I guess one of the more valuable ones is logging while drilling that people are getting. And it's there. There may be some other sensors that people might want. David mentioned earlier wired drill pipe. So NOV purchased a company that was making a pipe that had an inductive coupler at the pin in the box and a piece of wire, a coaxial wire in between them. And that lets you send signals from near the bit to the surface at extremely high speed. And, he didn't like me saying this, but I said, "Oh, great. Now we're going to get the same wrong answer faster."
Yeah.
So what I saw
wasn't ready.
No, it wasn't ready, but now it is. Yeah. But so the reliability is improved, measurements are improved. But one of the fascinating things is the top of this piece of pipe. At the bottom, we've got a sensor in the drill string that's got a battery in it. And so that wire is sticking up at the top through the rotary table into an area that could have gas. So you have to keep the voltage very low so that you cannot get a spark that would ignite the atmosphere and burn up the rig. Pretty good plan. So what was done was you keep that voltage low, but then there's voltage drops over the wire. So you need repeater stations along the way. So there's essentially a battery pack and a repeater station going dual conduction up pipe and down pipe. And they're about 500 meters apart. Well, guess what they did? They managed to condense their electronics and battery pack, and they ended up with a space about the size of a big softball that you can put sensors in. Yeah. And it can be, different companies can put sensors in. And lo and behold, we now have sensors along the drill string. So in the past, our downhole data streams came directly from a tool over an acoustic signal, or over a mud pulse signal. And now it can come wired. In shallow depths, it can come as a radio transmission. And then some people are working on banging on the drill pipe and sending an acoustic signal through the steel. But all of these are at faster rates. The fastest is the coax and the inductive coupler. But what you get is an amazing thing, and some work was done by some BP engineers when it was brand new, and it just amazed me that as you drill, you measure something at the bottom, and you drill down a little bit, and you get to the first knuckle, which is the first sensor in the drill string, and you measure the same thing at a different time. And when you drill faster, you get to measure it a third or a fourth time. And you can see changes in the well bore in real time. And well, real time being however fast you're drilling times, with 500 meters.
Yeah.
But they were seeing damage to the formation as they drilled, and they were able to change their mud weights so that they could avoid some of the problems that they were having. And it's things like that that will give us brand new data streams, because it's really a different set of physics that allows us to measure stuff.
Yeah, I mean, I think you're right, Fred. We do have that ability to access the data up and down now, which I think a long string was probably has been the biggest surprise to everybody, is that, you know, there are things we hadn't thought of, like cleaning the whole practice. All your rule of thumb practices become actual. You know, there's no more guessing and calculation. It's actual readings. So weight on bit, live. You know, I think all of those things. We learned surprisingly that you know, engagement of the bit into the ground was like once that whole transition with the ways that we were doing that was causing vibration. And
Yes.
at first everyone was like, surely not. I mean, you know, as long as you're doing it consistently, but a computer doing that took out tons of vibration that other people had thought was coming from other things. But just the actual engagement of the bit to the drilling process was a huge win. So it's really having the sensors there to be able to read everything. So that I think there's a lot more we're still going to learn as we run with these. It's one of the hard things we've had with selling the use of wire drill pipe, because you learn something new every time. So the stories are different, which really is a hard sell, because you can't, you know, it was originally was just a very expensive insurance policy. And you'd ask people, were you planning on screwing up on this well? No, I don't need any help there. You know, none of us plan on crashing our cars either, but we have insurance. So that was one of the hard sells to everyone was, you know, do you suck enough to need wire pipe? Yeah, I do. You know, nobody was asking that question. So what's really become good is where it starts to fix processes. And when you're closed looping to the machine, I mean, we're doing, it's pretty normal now to see stick slip, and immediately the system just engages. You don't turn on anything. You just let it do the closed loop with the machinery, and those kind of things are where the dollars are at. And so I think just visualization of everything down there. Temperature is probably going to be more valuable over time. I don't think we watch it as much as we should, and formation evaluation is going to be, you know, is still out there for us to learn more about. But yeah, I think everything else we're covering, you know, load and speed and weight on bed, and you know, there's plenty of sensors down there.
Just wanted to say that
I'm going to go back to James and just answer the second half of this question.
Oh.
What I want to see is temperature of the annulus.
Yeah.
And if you've got multiple wired pipe sensors and you see temperature changes, a lot of times a kick comes in with a temperature change. And now you can see within 500 meters of where the kick was, and
calling you, Fred.
yeah, well, I'm going to take the battery out of it in a minute. Okay. But anyway, you would be able to know where the kick came from. And if it wasn't kicking, at least you would have an indicator to raise your antenna and start thinking about this stuff. So I'd like to see a real accurate temperature sensor.
So what if we had temperature plus like you know, like a PWD?
Yeah.
Like
I'll take temperature from the PWD. The other thing I want is a salinity or a resistivity sensor, because a lot of these kicks comes with salt water. So you could see that there's a temperature change. You could see there's an increase in salinity in your mud at these different points, way before it gets to the seabed, way before it gets in the riser.
Right.
And you would say, aha, I need to circulate this kick out my choke and kill line so it never gets in my riser.
Mm.
And the other thing, and this is for the horizontal wells that we're drilling today, I'd like to see a pretty accurate 360-degree caliper. It doesn't have to be as accurate as a wireline log, but it needs to show you at least what's happening, and you can see a pack off above the drill pipe before it actually occurs.
Mm.
So there's some things like that people are working on and will work on, and there are other sensors that we can use that will give us information in near real time in a way that it will allow us to make this much, much safer and also more efficient.
I think there was a similar question I asked Fred Dupriest about was the caliper, and he said that for most LWD applications, it's too close to the bit, and that it needs to be further back, almost above the BHA, in terms to be able to make sure that it gets the proper hole conditions.
Right.
So maybe with wire drill pipe, he can put one like every 50 feet, all the way to the surface.
That's too many. It's not good every 50 feet. So we're going to say 500 meters. But the other, there's so many things like that. When you hear and read the papers from Eric Van Oort, all these things that we were done. Randall Thomas is on the call. They told him that you pump a sweep, but in a horizontal well, it just goes over the top of the drill pipe. And Eric says you have to rotate. So you need to understand that you're starting to see these changes, and you have different answers for different problems.
All right, so let me get into some of these questions and a quick comment. So Graham Menzel-Wilmot said, David and Fred, great insights. Thank you for the conversation. Graham's going to actually be on the show November 13th, I believe. He's going to be actually coming on the show. So great to have current guests and future guests coming on here. And speaking of previous guest, Brian Gallahan has actually been on the show before, the CEO from AccuScribe. He says, is there in the near future use virtual reality or augmented reality in remote operations?
Yeah, we're using it. COVID helped a lot, particularly. I mean, we developed, we're using other people's stuff, but a hat mounted visual and camera system and interaction. And it was originally for Novos, just because we had so many going out. We needed our best experts everywhere. We didn't have enough of them. And so you got the hat with the system, right? So that you could have remote connectivity. But that was actually adding in the ability for this VR and augmented reality in service, with the headset. And it's become really popular globally. So that is happening in there. I do wonder, but in well, I don't know if much of that is going on, but I know in the service part of our business, we're seeing a ton of this being done with our tracker headsets. Yeah.
And I think heads-up display is, I assume that's what you mean by augmented reality, and I think that's going to be very helpful for the people on the rig floor and also for the technicians. So what you're just describing, David, is you walk into a console and this augmented reality that's over here on the side of your glasses says, this is where you need to go. This thing right here is what you need to remove and replace.
Right. And I mean, and we are doing remote cabins, and so we've actually got these high res. You're actually seeing better view of the drill floor than if you were sitting in the cabin. So there's a whole world of camera insight and using cameras and we're playing with drones. We'll see how that goes. But the ability to see what's going on and replicate what's behind something, that's really where it starts to help us. What am I looking at before I open something or before I take something apart? And, I think there's a lot of opportunity there. So yeah, I think we're going to see more and more of it. For a long time, it was a cool idea that, I'd see it because I'd have teams of people, everyone who works in the virtual or 3D space is like, let's do it. But finding value, you're like, show me really how it helps. Don't just show me something cool. Because there was a lot of cool with no value. So I think there's going to be more. We're really starting to see places where it can help.
A lot of cool with no value.
There's new camera technology coming out as well, not just infrared, but some things that can see through fog and rain.
Yeah,
you're going to see some of that will be more helpful.
We're trialing some for humans on the rig, so that the machine, you can actually code it in now. You remember Fred, you've sold it a couple of times. These slow down the machine systems, but so they don't crash. All your collision avoidance. You remember multiple rigs we designed with that in, but now they're going to be able to actually see digitally inside the control system, human beings, and start responding to that. So that's a great advancement.
So another question from Barry. Great insights, gents. What do you guys think the future of automated casing running operations looks like?
How about that? That's a culture barrier right there, isn't it? There's room. The systems can do it. There's a lot of probably our biggest barrier on automating casing running is relational. It's that people know people and trust them, and that's what we're going to do. And we're going to go with the crew. I'm much more comfortable with this. So even though, I mean, I think Fred and I were involved in creating systems that could build stanza casing, but it creates a complicated relationship. We did the express rigs, and they had to have full-time casing crew on there. But I think that barrier needs to be broken. I really like a lot of the casing running tool capabilities because they simplify the whole process. So I think there's room. It's one of those things that we should be doing a lot more, but I don't see enough of it. If that makes sense.
There's some very sophisticated threads that are one of the main issues, I think.
Yeah.
But once you make it up, you still want to pay attention to how you put it in the wellbore.
Yeah.
And what are happening with the pressures in the wellbore.
Yeah,
so years ago, we talked about an instrumented casing shoe, so that I had some kind of telemetry system that would be able to send that information back up, so you could see actually what the surge pressures were. And then once you got there, you could see what the pressures were as you cemented it in place.
I think there's room, as well as just having instrumented casing as another, another area. I don't think we've cracked the code. Once again, you see people presenting it, but I don't see it being there yet. So there's still barriers, but there's good work to be done in that space. Is the best way I can think of describing it.
Yeah, the wired pipe technology doesn't lend itself to casing well. But the acoustic might be the way that you go. So it may be acceptable in certain depths while that still works. The problem is that every connection you get some kind of echo, and that ringing is really difficult to understand what the communication is.
Good problem for someone watching to solve. So
yeah, go fix.
Yeah.
Make $1 million.
So Philip's got a question here. Any cool / good idea came out of this that the industry could use for drillbotics?
Well, like I said, the guys from A&M are trying to get a patent to have a different control channel for an auto driller based on mechanical specific energy. And what we saw in the lab was, in their lab, what they did was simple and very, very effective, so that they were able to drill without damaging the bit through these transition zones, and they came out of the transition at the right speed. And I think that was probably the first one. There's some new bit ideas. One of the teams in Norway and one of the teams in Germany. The Germans are working on a new hammer bit. I think they've got a patent on it. That's certainly pending. The one in Norway that decided not to go for a patent, but they're working with a bit manufacturer who probably will start building that bit design along those lines.
Let me ask you. Can I ask you a question on this thread? That I've heard that the DUPS group, the drilling uncertainty prediction guys, are going to be joining in. So does that? I know Philippe's background, so I'm like, is that going to render some new AI stuff for us?
Oh yeah, absolutely. And so as soon as we get a common denominator for the communication, and I don't mean the protocol, but I mean the message, that WITS and WITS ML is not sufficient. We have to have some other things in place. And so I think like I said earlier, I'll just tell the kids, we told them next year, you're going to be communicating based on this new standard. You'll have to build that into your system. And then these guys who say, I want to be second, well, they can be second to a bunch of students who are already doing it.
There you go.
Just to let everybody know, David mentioned DUPS. DUPS is the Drilling Uncertainty Prediction Technical Section within the SPE. So we've covered two different kind of SPE groups. We've got the DSATS Drilling System Automation Technical Section, which all three of us are in that group. I know that. And I mean, David should do this way. David is our SPE technical drilling director, technical board member. He's the
technical director, but
he's the guy in charge. And then also the Drilling Uncertainty Prediction Technical Section, and then also one of my favorites, the ISCWSA, or the Wellbore Positioning Technical Section.
That's right.
So
that's our three.
Those are the three. Those are the only three drilling
Yeah,
those are the three drilling segments. So if you're wanting to get involved and be in conversations like this and in future ones, be sure to look those three up. So, and then the ICWSA event is actually coming up. So please be sure to go and register for that.
So this year, the students need to build a mechanical rig and drill a directional well. And this year they have to drill through 2 targets. And we're not going to tell them what the targets are until right before the competition. So they'll drill a well that will build and then drop, build and extend and then drop. And guess what? Because of Mr. COVID, we have a virtual rig competition as well. And one of the schools in Norway is entering 3 teams. They're going to have one team that builds the physical rig. There's another one that's going to make a digital twin of that rig. And then the other one's going to have an automated planning and execution program. And when they do that, it's going to be one of the best papers we've read in quite a while.
That's great.
Wow.
Even if they don't win, what they've learned is just phenomenal.
For anybody that is watching that, either has an alma mater or is a student that is not familiar with robotics, how can they get either their school, their alma mater, or what? How can they get involved to be able to start getting involved in doing the Drillbotics competition?
Go to drillbotics.com. If you misspell it, it'll probably still take you there. And there's guidelines and explanations of what you need to do. There's a registration page. There's videos and pictures and all kinds of stuff.
And also,
all previous work.
If you think it's cool, feel free to get your company to sponsor. Just kind of throwing that one in.
You can be a sponsor for $500 to $5,000, and we need money so that we can keep these guys going. What we have to do.
I mean, if there's patents coming out of it, it's probably not a bad investment.
No. We don't get a dime of that. No. All the intellectual property belongs to the students or the school, whatever their policy is. But for us, if we don't have enough money this year, then we have to limit the number of finalists.
Right.
So anybody that can contribute a little bit, will advertise you, and they'll all know who you are, and the people that are going to the site will get to know who you are.
There you go.
That's it. Robotics.com.
Thanks, Philippe.
All right. Anything else that you guys want to cover? I mean, we're coming up on 90 minutes, so I don't really need to ask questions. And if you guys, if I missed a question that you asked in the comment section, please run it back through. There were tons of them coming in, and it's difficult doing all of this and keeping track of all those. I missed somebody's question like a week or so ago, and they called me and chewed me out for it. So I apologize if I missed your question. I am not dodging anybody's in particular or anything like that. But if you make it short and sweet and put a question mark at the end of it, it makes it a lot easier for me to find. So feel free to do that.
Well, I don't have any other questions, but I can close them with what I think. I'm really excited to see that this has. Hey, Robert. Glad to see you.
You know everybody.
You know everybody. What started off as
my fans cover the entire spectrum of the
that's right,
or at least just all your fans that are on Facebook. There we go.
Well,
thanks,
really,
Robert.
What started off was some work that Amoco did years ago to build an automated rig, and the computers were in a trailer, to give you an idea how long ago it was. And a lot of the machines were hydraulic. And so what they achieved was phenomenal, but it just wasn't scalable. And so what we started with was these integrated control systems, and it was scalable to a small extent. And what we're doing now is making it scalable for multiple companies, for people that don't know the oil industry but know how to write apps, can start putting some of these things together that's going to improve the safety and efficiency of the drilling business. And to have been part of that and see where it is, to see the people within these 3 technical sections you're talking about, the students that are coming, I'm very confident that we've got the right people in place to carry this into the future. And I'm excited to see how this has evolved.
It's good. I agree, Fred. I think the fun part of our journey is that things we all dreamt about are happening, and the exciting thing is there's tons more to do. So I think the engagement in going from automated to autonomous systems is really, I think we're in that era now where automation is going to be what we see for the next few years, and knowing it, understanding it, engaging it is critical. But also knowing that there's a lot more we're going to be doing out there that is there to get involved with. It's going to be fun.
So we got two more questions I want to be able to hit you guys with. Opinions on well control systems, i.e. a system that can pick up the drill string, spaced out, and shut in the well in the event of a kick or potential kick. I know we talked about a little bit of that, but
yeah, it's that's fully possible. It just takes someone wanting to do it, and there's all the risk challenges of who's taking what responsibility for what. But there's nothing to stop us doing that in any way. I know we're playing with it. I know others are playing with it, but it has tons of risk in practicality. So that it's not doable. It's all very doable, and we should be moving towards it. Some of the MPD automation work's been helping a lot because it helps people to see how you can work with models. And I think when people understand that you can have a model that's kind of feeding and you're verifying as you go in a well-controlled situation. But I think that's the most obvious one that would be really valuable with a lot of people concerned about doing it.
When Bill Cateritz was doing some work with automated drilling parameters, he set his system up. And he first went to the rig and he explained it to the driller, and it was just an advisory. It would tell the driller, this is what you should do. And the driller then would change the settings or choose not to. And then the next step was the driller would actually allow the machine to control things. That's what we're going to have to do in the world of well control. We'll put it out there in phases. We'll use it as an advisory.
Yeah.
And the drillers that don't take the advice and burn up a drilling rig will probably take the advice next time. Mm-hmm. But if the machines and the sensors are not adequate, we've got a man or woman in control that can make that decision. And if it's not good enough, people will continue to work on it until it's good enough. The risk is high, but probably acceptable if you do the right things. Right. And the reward of no damage to life, rig, or environment is huge. So it's certainly a place we want to go.
I will say when we've done even touchscreen control of BOPs, it's it's a world of complex because you get into dissimilar systems. If you're working in Europe, you can't have the same computing system. That you have to have a dissimilar system so that they don't fail the same way. Even all of our BOPs are independently controlled on purpose. They're generally not network controlled, although there are some, but that's all for safety purposes. So there's just all of those things to think through, but not a technical barrier really at all.
All right, final question for you guys, and we'll get your closing thoughts. With all this downhole data available, is it able to prevent total failure, identifying initial damage other than vibrations? I think there are enough failure cases for us use of machine learning.
I think you're right. I think it's more being in the position to do the work. I think this is coming. I think every failure case that we know about, and though we're not in any absolute knowledge in anything, that's just the truth of the earth, as we're constantly learning new things. But I think teaching the system, and I know ConocoPhillips did some great work in this space of just trying to read what's going on in the well, and that was a lot of good big data work in the background in their deep system. But I think those types of things are coming next, where we're going to need to get the systems to start to at least understand common cases of failure, and there's a ton of them out there. There's things we've assumed. We've learned this with wire drill pipe, things that we assumed were happening that weren't, like whirl, backwards whirl. That turned out it wasn't actually happening down in the BHA. It's just that's where we thought it was happening, and we learned with ConocoPhillips also that it was further up the string. We just had no measurements there. So I think there is a ton in that space. It's a lot of the fun stuff ahead of us, I think. Fred.
I think we got to get better at some of the data that we will use for all these analyses. One of the problems that we're dealing with right now is what time is it? So we've got a downhole sensor that may be a memory-only sensor. We have some that have a lot of data stored by memory, but some of it is sent by burst to the surface. And some of these are averaged over, so you get a maximum and a mean and some kind of variation, RMS variation. And they're not synchronized. And so to do that analysis, you need to know what else was occurring. So today the vibration is looked at independently. And for that reason, that's what people can see and use that data for. But if you could take the other pieces that were going on at another place, it might be a resultant of what's going on downhole, and you can correlate that through time, you'll probably have a better understanding of the process.
Well, guys, thank y'all so much for being here on the show today. I really do appreciate it. I know that the industry appreciates it as well. So for anybody who hasn't yet, be sure to check these guys out on LinkedIn and get connected with them. David Reid, obviously the Chief Technology Officer and Chief Marketing Officer, because one job's not enough. And also the SPE Technical Drilling Director. You see, I got it right that time. Either one of them are absolutely amazing resources and easy to be able to reach out and get in touch with. So if there's students or somebody that's wanting to be able to help out their alma mater, get into Drillbotics, be sure to go to the website. We already posted that up. If I can find it again, I'll do it again. But nope, can't find it. Okay, never mind. But otherwise, get in touch with Fred Florence. Any closing statements from you guys? Anything that you guys would like to be able to put out there to the industry and tell them to get busy doing?
Fred.
Pass the buck.
Keep getting better. That's what we've done as an industry since its inception. Is we never accept where we are, and we learn more in so many different ways, and it's an exciting place to be. Even in a downturn, it's still an exciting place to be.
And I'll say, don't waste the good downturn. There's I think our best work's always done in this time. And if you're frustrated at not getting buy-in of your ideas, you might need to change your ideas. Because if you have a good business idea, something that can really work, this is the era that you can really get it to happen, because people are hungry for something that brings value.
Well, as always from me, thank you guys both for being here. For everybody that's out there watching, please like, share, connect. Let other people know about the show. We're doing Friday at 10 a.m. For the foreseeable future. Up next week, we have Ed Stockhausen. I don't think he's ever been on a podcast, a live stream, any of these things since his retirement. He probably hasn't done anything other than like SPE talks, even when he was still working and stuff. So this is going to be an absolute treat for everybody that's in the industry. If you are in the directional drilling or MWD business, you have done something that has been affected by Ed Stockhausen. There's the whole thing called the Stockhausen effect. If you don't know what that is, you need to go look it up and research it before next week's show, because we're going to be talking all about it. It's going to be absolutely phenomenal. The week after Ed Stockhausen, we're going to have Fred Dupriest. And then the week after that, I think that's the 30th. I don't have a guest lined up yet, but then it's going to be Matt Flannery, then Graham Mensa-Wilmot, then David Ransom Wood. And then after the Thanksgiving break, we're going to come back with Dr. Samuel Rubello for the history of mud motors. So we've got an absolutely stacked lineup. I look forward to having all of you guys back, not only for next week, but for the subsequent weeks. I am doing my absolute best job to be able to keep bringing you guys and gals, all of the industry leaders, the legends, the people that we can truly learn from, so that we can fill the gaps going forward, as we have a lot of people leaving the industry, and we need to be able to step up our knowledge and expertise going forward. So thank you guys once again. Thank you guys for being here. And as always, oh wait, hold on. I'm not going to screw it up this week. Let me cue this up. There's the button.
Screw it up.
Didn't do it. I didn't do it. All right. Thank you guys for watching. As always, know your industry.